So the last thing we're going to look at are residuals. A residual is the difference between what was observed and what we are predicting using the linear equation that we have created for our data. A residual kind of gives us a little bit of an idea on how good of a relationship we have actually found. If we have really big residuals, maybe this isn't the best relationship. If we have really small residuals, that's good. That means that our predictions are really close to what we were actually seeing. So a residual is calculated by taking the y value that you observed, and this value you're going to find in your data table, and subtracting y hat. So this is found from the linear equation that you created for your data. So let's look at an example. So we have an equation to model the relationship between the number of hours a student studied and the score they received on an exam. And the equation for that is y hat equals 5.43x plus 76.4. And then I also have the original table of values that we used to create this linear model, because we need that data table in order to create or to find the y observed value. So find the residual for the student that did not study for the exam. So if they did not study for the exam, that means that their x value is 0. They studied 0 hours. They didn't study. So I'm going to go to the table and I'm going to find that student. So here he is. So this student did not study for the exam and they scored a 75. So my y observed, which I'm going to shorthand to OBS, is equal to 75. Their exam score is a 75 because they did not study. So now I'm going to find y hat using the equation. So 5.43 times 0 plus 76.4. 5.43 times 0, that's just 0. So our answer is the y-intercept. If a student didn't study, they can expect to score a 76.4 on the exam. So then the last step to this is to calculate the residual. So you take the value that was observed minus the value that was predicted. And this is negative 1.4. So our prediction is a little bit higher than what we observed. Our observation is lower than what's being predicted. So one of the things that we can also say about this residual is that the equation is overestimating the score for a student that did not study. Because the value from our equation is higher than what we actually saw. So our equation is overestimating. But it's not too bad. Negative 1.4 isn't a terrible residual. Okay? This full thing, all the calculations I did here is what you need to do anytime you're asked to find, calculate, evaluate, whatever for the residual. If you don't do all of this, find the observed, find the predicted, find the residual, then you haven't found the residual. Just telling me, oh, it's overestimating, that's not enough. Okay, if we're finding the residual, that means we have to be doing some sort of calculation involving what we originally saw and what we're predicting. So now find the residual for the students that studied for 1 hour. So if we look at our table, we see, oh, I've got one student here who studied for an hour. Oh, here's another student that studied for an hour. We need to calculate the residual for both of them. Okay, if you have multiple x values for the value that you're being asked to find the residual for, you should find the residual for both of those. So my first observed y value is 78. So if I take my equation and plug in 1, because we're looking at the student that studied for 1 hour, we get 81.83. So the residual for this student is their actual score of 78 minus the predicted score for this student of 81.83. And that's negative 3.83. So for this student, the equation is overestimating what they would have scored on the exam. So now we're going to do the same thing for the second student. So the second student who studied for 1 hour scored an 85 on their exam. So the y-hat equation is the same because they studied for the same amount of time. So their predicted score would be the same value. So then their residual here is 85 minus 81.83. That's a positive 3.17. This student did better than what we saw from the prediction. Okay? Typically, if you have a fairly good model and you have something like this where you have two different values for the same x, you have two students that studied for 1 hour, typically it'll be good to have one negative residual and one positive residual. Okay, and they're about the same value away from each other. Okay, or away from that line. We're 3.8 below, 3.1 above. This actually isn't too bad to see. Okay, so this guy was an overestimate for this particular student. So if this student had this model, said, oh, I can get a B if I study for an hour, and then they get a 78, they might be a little upset. However, this student, the equation underestimated what they scored. So this student uses the model, says, ooh, I can get a low B if I only study for 1 hour. And then they get an 85. Cool. I got a few more points than I thought I was going to, because the equation underestimated what they would score on the exam. So here we have a few examples of how to calculate residuals, and just a little bit about what the residual